we have higher order derivative. Now, if we speak about higher order derivative, this means that we can take the derivative of a certain function up to, let's say, second derivative, third derivative, fourth derivative, and so on. So we call it as higher order derivatives. Now our notations for the first n derivatives, so we have, if we have here our function f of x, then its first derivative we can rewrite as f prime x. That is the first derivative. Its second derivative we have f double prime of x. Its third derivative we have here 1, 2, 3. Third derivative of your function f of x. Fourth derivative we have here 1, 2, 3, 4. Okay, or instead of writing this one, we can make use of, let's say, first derivative, second, third, fourth, or instead of this double prime, we can write second derivative. But you have here a parenthesis. Okay, this is how we write higher order derivative. Also, we have third derivative of f of x, and then fourth derivative we have this one. This is how we write the highest or the higher order derivatives. These are the notations. Also, instead of writing this one, let's say your function y, we have here y prime, that is the first derivative, second derivative, third derivative, fourth. So we can write here as fourth derivative, fifth derivative, sixth derivative, and so on. So this is another notations. Also, we can make use of, let's say, our function, the derivative of y with respect to x. This is the first derivative of y with respect to x, or second derivative of y with respect to x, or third derivative of y with respect to x, fourth derivative of y with respect to x, and so on. This is also another notations in writing higher order derivatives. So this is the derivative of y with respect to x. Also, we can make use of, you say, we have our function, we have derivative of y with respect to x, that is the first derivative. Its second derivative is this one. This is how we write the second derivative of y with respect to x. Third derivative of y with respect to x. Fourth derivative of y with respect to x. That, and so on. Okay, so these are the different notations when we write our higher order derivatives. We have here our example of higher order derivatives. We have y equals 2x to the 7 plus 3x to the 4th minus 2x plus 1. Find the fourth derivative of the given function. This is our function. Now we're going to find its fourth derivative. So when we solve this problem, of course, we will start by taking the first derivative. We have y prime, that is the first derivative of this function, equals 7 times 2, that is 14, x to the 6 plus 4 times 3, that is 12x cubed minus 2. This is the first derivative of this function. Next, second derivative, that is equivalent to 6 times 14, 6 times 4, 24, carry 2, 6 times 1, 6, 8, 84, x raised to 5 plus 3 times 12, that is 36 x squared. Derivative of 2 is 0. Okay? 6 times 4, 24 carry 2, 6 1, 6, 7, 8. Okay. Next, third derivative. Okay? That is equivalent to 5 times 84, 5 times 4, 20, carry 2, 40, 42. X raised to 4 plus 36 times 2, 2 times 6, 12, carry 1, 72 x. So this is the third derivative. And then the fourth derivative, I will write the fourth derivative as this one, which is equivalent to 4 times 420, 4 times 0, 0, 4 times 2, that is 8, 4 times 4, that is 16, x raised to 3, plus the derivative of 72x, that is 72. This is now the final answer, wherein the fourth derivative of this function is equivalent to 1680 x cubed plus 72. We have another example. Find the fifth derivative of y with respect to x in y equals 2 over x squared plus 3x over 4. Again, this is fifth derivative. So we will start with the first derivative. Now, if you have noticed, we have here a fraction. So the best way to solve this one is to convert this fraction in terms of a not fraction like this one, which is equivalent. Okay, I will write first the equation y equals, instead of writing 2 over x squared, I will write here 2x negative 2. I will raise this up. Okay, I will transfer this new denominator to numerator. Now, if you raise this term, the exponent becomes negative. So notice, this is all in numerator. The denominator here is 1. Plus, this one is 3/4 x. Okay. This is the best way or the fastest way to compute the fifth derivative of this function. Okay, first derivative, that is equivalent to negative 2 times 2, that is negative 4, x raised to minus 1, that is negative 3, plus 3 over 4, and then derivative of x, of course, 1 with respect to x. That is the first derivative. Second derivative, y prime, y double prime, that is 3 times 4, that is positive 12, x raised to negative 4. You have to subtract your exponent by 1, negative 1. Or 1, so that is negative 4 minus 1, that is negative. Negative 3 minus 1, that is negative 4. And then this one, the derivative of any constant is 0. So this is the only answer for the second derivative for this equation. Next, the third derivative, that is equivalent to negative 4 times 100 times 12, that is negative 48x negative 5. And then the fourth derivative, I will write this one. Fourth derivative, you have to multiply this. 5 times 8, that is 40, carry 4, 5 times 4, 20, 24, 240, x negative 6. And then, we have the fifth derivative, that is equivalent to this one times this one, so negative. Negative 6 times 0, that is 0, 6 times 4, that is 24, carry 2, 6 times 2, 12, 13, 14, x raised to negative 7. So, rewriting this one, sorry for my writings, y to the fifth derivative, so that is also equivalent to negative 1440 divided by x raised to 7. So, make this one your exponent as positive. So, you have to make, instead of numerator, you write this as your denominator. So, the final answer for the fifth derivative of your function, that is equivalent to negative 1440 over x to the 7th power. We have example number 3. Find the second derivative of f of x to the equation f of x equals 3x minus 4 over 5 plus x. To solve this problem, of course, I will write first our function f of x, which is equivalent to 3x minus 4 divided by 5 plus x. Okay, this is quotient rule. You have your u over v. So the first derivative of this function, that is f prime x, which is equivalent to 5 plus x times the derivative of 3x minus 4. Derivative of 3x minus 4 minus 3x minus 4 times the derivative of 5 plus x divided by 5 plus x raised to 2. So that we have 5 plus x times the derivative of 3. Okay, I will write here. I will extend our computation. That is 5 plus x times the derivative of 3x, that is 3, minus 3x minus 4, derivative of 5, 0, derivative of x, that is 1. Okay, divided by 5 plus x raised to 2. So that when we distribute this 1, 3 times 5, that is 15 plus 3x minus 3x plus 4. Negative times negative, that becomes positive 4. So that 3x minus 3x 0, so 15 plus 4, that is equivalent to 19. Divided by 5 plus x squared. 5 plus x squared. Okay, so that is our first derivative. Now to compute the second derivative, of course we have to raise this up. So this can be rewrite as 19 times 5 plus x raised to negative 2. That is the easiest way to solve the second derivative, because this is product rule. So second derivative of your function f of x, that is equivalent to multiply this 1 by 19, 2 times 9, 18, carry 1, 38, that is negative 38, and then 5 plus x, negative 3 times the derivative of 5 plus x, this is derivative of u to the n, nu n minus 1 du. The derivative of 5 plus x, that is equivalent to derivative of 5 equals 0, derivative of x, that is 1. So 1 by this one, that is equivalent to negative 38 times 5 plus x raised to negative 3. Or our final answer, make this one as your denominator. So negative 38 over 5 plus x raised to 3. This will be our second derivative of your function f of x. So this will be our final answer for its second derivative.